We're going to start, as usual, with a quiz. We're going to subtract one rational expression from another. First rational expression is x squared minus x minus 6 in the numerator, divided by x squared minus 4. Second is x squared plus 5x plus 6 numerator, denominator x squared minus 9. The second is subtracted from the first. So go ahead and work on that, and we'll discuss it. Okay, everybody's had some time to work on it. People have made various errors and made various progress, but everybody seems to have the general idea. Okay, so first, what's the first thing we want to do? And again, if you're watching this, you should have paused the video ideally and work this out. You're not going to learn a whole lot just by watching me do it, unless you already know quite a bit and just want to see a quick example. Okay, so first thing. I'll say factor every expression. I could even say factor every polynomial because the numerator of each fraction is a polynomial. The denominator is a polynomial. I'll just leave the word expression there, assuming everybody knows what I mean. So let's just take x squared minus x minus 6 equals, well, that's x minus 3 multiplied by x plus 2. And of course, you need to review factoring of trinomials. These are fairly easy trinomials to factor, which means I'm going to probably mess something up. Okay, so anyhow, I believe that's how this first numerator factors. The first denominator is x squared minus 4. And of course, there's a special product, difference of two squares. We have x minus 2 times x plus 2. And again, if you don't know how to factor the difference of two squares using the special product, you need to review that. Okay. Then we have x squared plus 5x plus 6, which equals x plus 2 multiplied by x plus 3. And then x squared minus 9, which equals, again, difference of two squares, x minus 3 multiplied by x plus 3. So our calculation becomes first numerator, x squared minus x minus 6 is x minus 3 times x plus 2. Denominator is x minus 2 times x plus 2. And then we subtract. The second numerator is x squared plus 5x plus 6, which factors as x plus 2 times x plus 3. And that's divided by x squared minus 9, which is x minus 3 times x plus 3. Okay, well, that's always the first step when you're dealing with rational expressions. Sometimes they're already in factor form. If they're not, you need to factor. Second, simplify if possible. Well, on the first fraction, x plus 2 in the denominator divides into the x plus 2 in the numerator, giving us just 1, which gives us 1 times quantity x minus 3 over the quantity x minus 2. So the first fraction just becomes x minus 3 over x minus 2. The second rational expression, which is subtracted, excuse me, for writing the plus sign. Very similarly, we have the x plus 3's that divide out. And we get x plus 2 over x minus 3. Now, you might want to cancel these, draw lines through them. Be very careful if you do. Make sure you follow the rules. You can only divide a factor of the denominator into a factor of the numerator. If a factor of the denominator matches a factor of the numerator, yeah, okay, it can be canceled. Otherwise, no. Be very careful with that. Okay, so now we got a couple of pretty simple expressions. We're doing x minus 3 over x minus 2 minus x plus 2 over x minus 3. Well, let's write that up here again, so we have a little room to write things out. Okay, so just continuing where we left off. Third step. Find the common denominator, which I'll abbreviate denominator. I believe everybody will know what that means. Okay, well, what's the common denominator? In this case, we only have one factor in each denominator, x minus 2 and x minus 3. If we're going to have a common denominator, it has to contain both of these factors. We need x minus 2 for the first expression. And we need x minus 3 for the second expression. So CD, which is the abbreviation I'll use for common denominator, is x minus 2 times x minus 3. For express each fraction I'm going to be a little wordy here, as an equivalent fraction. With the common denominator. So let's write out our first expression, x minus 3 over x minus 2. If we want the denominator to be x minus 3 times, x minus 2 times x minus 3, then we're going to have to multiply by some expression with the denominator x minus 3. The expression that we can use to get the equivalent fraction is x minus 3 over x minus 3. In other words, if we multiply any fraction, any expression by x minus 3 over x minus 3, then as long as x doesn't equal 3, which would make the denominator 0, but then we're multiplying just by 1 in slightly different form. Okay? X minus 3 over x minus 3 is 1. We multiply the first fraction, first rational expression by 1. We don't change its value for any value. It'll have the same value for every value of x. Okay? Well, then we're going to write out the second. We'll put a minus sign here and write out the second expression. Second fraction, x minus 2 over x plus 2 over x minus 3. And what we have to then do is multiply that in order to get denominator x minus 2 times x minus 3. Multiply that by a fraction with denominator x minus 2. And of course, then the numerator of that fraction also has to be x minus 2, since if we multiplied by anything that wasn't equal to 1, we would change the value of the original expression, at least for some values of x, for almost all values of x, in fact. Okay, so there we have it. And now we go ahead, just be careful, we're gonna write. Let's just go ahead and write it all out. We multiply the numerators of the first term. Okay, we have x minus 3 over x minus 2 times x minus 3 over x minus 3. And the numerators are x minus 3 and x minus 3. So multiply x minus 3 by x minus 3. And then we divide by x minus 2 multiplied by x minus 3. In other words, the denominators are x minus 2 and x minus 3. We multiply them to get the denominator of this expression, x minus 2 times x minus 3. And then we do the same with the second term. And have x plus 2 in the numerator of the first fraction. Okay, well, it's x plus 2 times x minus 2. And we multiply the numerators. We multiply the denominators, x minus 3 times x minus 2. Okay. Now, if we look at the first fraction, well, I'm sorry. We now subtract the numerators. We have the same denominator, so now we can say, okay, we have x minus 3 times x minus 3, which is the numerator of the first term, and then minus x plus 2 times x minus 2, numerator of the second term, all that over the common denominator, x minus 2 times x minus 3. At this point, I should have said we have a step 5. Which is add numerators, which is what we've done here. And now we go to the next step, which is called step 6. I'm sure I've got enough board here. 6. Expand the numerators. Well, let's write our expression again. We have x minus 3 times x minus 3 in the numerator, and then it's minus x plus 2 times x minus 2. The denominator is x minus 2 times x minus 3. We're going to expand the numerator. We're going to multiply x minus 3 by x minus 3. So that's going to give us x squared minus 6x plus 9. It'll be part of our numerator. And then minus x plus 2 times x minus 2. So we'd write the minus sign, and we'd be sure to put the result x plus 2 times x minus 2 into parentheses. Now, x plus 2 times x minus 2 is x squared minus 4. So we have minus the quantity x squared minus 4. So our numerator now reads x squared minus 6x plus 9 minus the quantity x squared minus 4. The denominator, we're going to keep the denominator factor, because sometimes when we end up simplifying the numerator, you'll have a factor in common with our denominator. So we don't want to lose the factors of our denominator. We can multiply them out later if we wish, but not right now. Well, now we simplify the numerator. That'd be step 7. I got a room here, so I'm gonna abbreviate this a bit. Numerator is x squared plus 6x plus 9 minus the quantity x squared minus 4, which equals x squared minus 6x plus 9 minus x squared plus 4. Remember the that minus in front of the parentheses on x squared minus 4 distributes. We have minus the x squared, and then we have minus the negative 4. Minus the negative 4 is what gives us a plus 4. Now we can combine terms. We have an x squared and an x squared, but one of them's negative, so we don't have an x squared. Okay, we end up with 0x squared. Now we have minus 6x. We don't have a x term on the second part of the numerator. And then we have plus 9 and plus 4, that's plus 13. So result is minus 6x plus 13 over quantity x minus 2 times x minus 3. Now, if it was negative 6x plus 12, we could factor out a negative 6 and get an x minus 2, which would divide into the x minus 2 in our denominator. But it's 6x, negative 6x plus 13, and that doesn't factor. 13 is a prime number, and 6 doesn't contain 13 as a factor, so we're not going to be able to simplify this. This stands in my classes as a final result. In some classes, you would want to multiply out the denominator. So maybe expand the denominator, which will give you negative 6x plus 13 over x squared minus 5x plus 6. Now, to test that, you pick up some off the wall number, x like 7. If x is 7, then what fraction do you get? We get negative 42, so you get 29, and 49 minus 35 is 14. You get 29 over 20. If you plug in 7 for the x's in the original expression and subtract the resulting fractions, it should end up 29 over 20. And if so, is a pretty good indication that you did this right. And one note I'll make here, result is this. I'm going to say step 8. Factor and simplify if possible. So I'll just leave that in there.
Also,
And then step 9, maybe if your instructor or whatever it is you're doing the problems for wants everything expanded, you could expand the denominator. Okay. I like to leave things in factor form because in factor form, it's easier to see if you really have a simplified expression. It's easy to see other aspects of that expression.